Welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's seminar is called Teaching NGSS in Elementary School, and we'll have a focus on second grade. Our presenters today are Carla Zembal-Saul, Mary Starr, and Kathy Renfrew. My name is Christina Crawley, and I'm going to be moderating today's program. Jeff Lehman is online with us to provide technical support. So we're going to go ahead and move directly to our presenters. Along with our three presenters, we also have Ted Willard joining us from NSTA. He is the director of the NGSS at NSTA, so Ted is going to be kicking off the session for us. And then we also have Carla, who is joining us from Penn State University. She's a professor of science education. Mary Starr, who is from the Michigan Mathematics and Science Centers Network. She is the executive director there. And then finally, Kathy Renfrew, who is an NGSS curator, and she's a K-5 science coordinator in Vermont at the Agency of Education. So with that, I'm going to pass the baton over to our presenters and Ted, and enjoy the session.
Thank you, Christina, and welcome everybody. Glad to have you here tonight. I know it gets to be a busy and busier time of year for you all, and so it's great that you're also working on your professional development. I want to just give a little brief background about the next generation science standards, make sure we're all sort of on the same page going forward this evening. Just to start off with is that we've got the standards themselves. They were developed by 4 organizations: the National Academy of Sciences, Achieve, the American Association for the Advancement of Science, and my personal favorite, NSTA. And so the standards were part of a 2-step process. First, the development of the framework for K-12 science education, and then the standards themselves. And the standards then are designed for the states that adopt them to drive curriculum, instruction, assessments, pre-service education, and professional learning. So let's start off with the first piece, the framework itself, and get a sense of that. And the big piece of the framework here is this idea of 3-dimensional learning, and the idea that teaching and learning should involve science and engineering practices, cross-cutting concepts, and disciplinary core ideas all going on together. These are all described in the framework, and if you're not familiar with the framework, I strongly encourage you to take a look at it. You can get a free copy of it from the National Academy of Press, or you can order a hard copy from the NSTA store. And so the first of these 3 dimensions that we've got in science education are the science and engineering practices. And these are the things that we want students to do as part of their learning and building. And it involves things like developing and using models, analyzing and interpreting data, constructing explanations, and designing solutions. The next piece here are the cross-cutting concepts. And those are ideas or concepts in science that aren't particular to physics or chemistry or biology or geology, but really cut across all those disciplines. And so the list here includes things like cause and effect, systems and systems models, structure and function. And then finally, the third dimension that we have here to pay attention to are the disciplinary core ideas. And those are things like life science, physical science, engineering, technology. And each of these pieces breaks down into some further detail, and that actually even breaks into further detail down the road here as you go through the different pieces. So that's all described in the framework. And then the writers of the standards took that framework and used it to guide their standards writing. And so the standards were developed by a group of 26 states, and each of the states in blue here had a team engaged. Could be a few dozen, or I think in some states, California, for instance, may have had over 100 educators who were providing feedback into the whole process. And there were 41 writers around the United States. A significant number of them were actually classroom teachers, almost half at the time the standards were started. At this point in time, we have 12 states in the District of Columbia, the states in green here, that have adopted NGSS. That represents about 3 in 10 students in the United States lives in a state that's adopted the standards at this point in time. and a lot of other folks are making use of the standards in various ways. So we've been talking about this. Let's look at a sample standard. I've got one here for 2nd grade. We have this idea: plan and conduct an investigation to determine if plants need sunlight and water to grow. So this is the description of what we want students to know at the end of instruction. It's really important to understand that this is what is to be assessed. It's not meant to say this is what a teacher needs to do in the classroom. Teachers have a total amount of freedom to decide what it is that they want to do. But it's the idea at the end of instruction. But this idea here taps into the practices, the core ideas, and the cross-cutting concepts, as shown here. So that first part, plan and conduct an investigation to determine something, that is dealt with here, about this idea about conducting an investigation to produce data to serve as the basis of evidence for an answer to a question. We then have this idea that plants need sunlight and water to grow. That's right here in this core idea. And finally, the idea that events have causes that generate observable patterns. That comes up in this idea of determining if plants need sunlight to grow. So all three of these different elements are captured in this performance expectation. And the idea behind the standards is that if students were to be able to do a task that was probing this, it would give us insights in their understanding of all three of these dimensions. And so with that background, I'm going to pass the baton off to our the amazing trio, the Three Musketeers, to talk about NGSS in 2nd grade.
Thanks, Ted, for that awesome introduction. And hello, everyone. Thank you for joining us tonight for the 3rd installment of Teaching NGSS in Elementary School. Tonight, we're going to be focusing on matter and its interactions at the 2nd grade level. My name is Carla Zembal-Saul, and I'm a professor at Penn State and a former middle school science teacher in Houston. I just put that up on the chat room board. I saw somebody was from Houston out there, so nice to have you joining us tonight. I have a research agenda, but also in my practice, I have an agenda that focuses on supporting elementary teachers in their learning as they begin to adopt practices and approaches for engaging students in constructing scientific explanations from evidence. And I'm here tonight with the rest of the trio, the rest of the Three Musketeers, my excellent colleagues, Mary Starr and Kathy Renfrew.
Hi, this is Mary, and I am the Executive Director of the Michigan Mathematics and Science Centers Network. We are a group of 33 centers throughout Michigan, and our focus is on professional learning for science and mathematics teachers. So I spend a lot of my time in professional development with teachers around the next generation science standards. And I am currently sitting in an office in outside of Chicago, Illinois. So I'm not technically in Michigan right now, where there is more snow than there is here. And I'll introduce now Kathy Renfrew. Go ahead, Kathy.
Thanks. Thanks, Mary. Excuse me. I am the K-5 Science Coordinator at the Agency of Education of Vermont. And just like these other two ladies, I do a lot of work around professional learning. I'm a former classroom teacher. I spent many years in the classroom. Probably most of my years were in grades 4 through 6. I am a curator. I'm also an online advisor. I just have this amazing passion for science, and I've been lucky enough to be involved in this process since the beginning of the Writing the Standards as a co-lead in the state of Vermont. So thanks, and I'm giving it back to Carla, I believe.
Great. Well, with that little bit of background, you can probably get a sense of why, when we were approached about developing this webinar series for NSTA, we jumped at the chance. All of us recognize the importance of engaging young children in meaningful science learning and scientific discourse and practices. That was clear from our own experiences as well as from the research base that underlies the framework that Ted was talking about, as well as the development of NGSS. There's also an important consideration that what happens in elementary school science can provide a strong foundation for future learning in science. And so we wanted to make sure that we gave special attention to that foundation, as well as focus on what teaching looks like in early grades when it comes to particular content and practices related to NGSS. We also know that it's important for many of us, the NGSS, ourselves included, have rendered us novice in particular ways, and we recognize the importance of developing a community of practice focused on elementary grades so that we can share and learn and continue to develop together as we move towards realizing the vision of NGSS in the classroom. And finally, we thought that this would be an excellent vehicle, the webinar series, to provide you with access to instructional resources for teaching science in elementary grades. Tonight, we will be, again, looking at second grade, and we'll start with the topics, the NGSS topics for second grade, and then we'll unpack performance expectation, physical science 1-4. That focus is on matter and its interactions, and the scientific practice that we'll take up is arguing from evidence. We've included in every one of these in every one of these webinars a video vignette that demonstrates some of the kinds of things that we'll be talking about tonight, and you'll have an opportunity to watch that later. And then we'll share a few approaches for supporting NGSS in the classroom, whether you're teaching matter and its interactions or other content. And also, Kathy will share in her capacity as curator resources to support instruction. So with that, I'm going to hand it over to Christina, our moderator. Thanks, Christina, for doing this tonight. And she's going to help us get started with this familiarity poll, familiarity with NGSS. And I'm asking that if you're actually an elementary teacher at the second grade level, when you put your mark on this continuum, if you would do it with the smiley face. So Christina, can you help people figure that out?
Yeah, sure. And so for this one, we're going to be using the clip art. So when you stamp directly onto the screen, and so if you can find the smiley face in that list of icons, feel free to put that either on the left, in the center, or the middle. And you can go up and down in the screen as well. There's no need to go directly on the line. That way we can see what fall in those three categories. So we'll give you maybe another 30 seconds or so, and then Carla, you're welcome to jump right back in.
This is great. Thank you, everyone. It's so nice to see so many elementary teachers, so many second grade teachers in the mix tonight. We really appreciate you taking time out of your incredibly busy lives to be with us tonight as everyone else. It looks like we have a really wide range of experience and expertise with NGSS. So regardless of your background with NGSS, what we're really hoping for are some really strong interactions tonight. So please be an engaged participant. You can do this by responding to the polls and using the chat window to share some of your ideas. And as always, please presume positive intentions, both on the part of presenters as well as other participants. And with that, Mary's going to get us started in looking at the performance expectation for tonight. So Mary, take us away.
Awesome. Thanks, Carla. So when we were first starting to plan this, we looked back at all of the experiences we've had working with elementary school teachers, and we wanted to really focus on what does it mean in NGSS to move beyond that activity, so that hands-on activities that we've all been doing in our elementary school classrooms for 25 years. And what does it mean now to take those activities and really move them into something that looks more NGSS aligned and is crafted in a way that students are beginning to engage with scientific phenomenon, and not just to engage in it to have an interesting experience, but to really collect data, to focus on the idea of constructing explanations around and arguments around that phenomenon. So really starting to understand the world as it works and to test their ideas about the world and collect the data and analyze it, and to do all of these things as scientists do it. So we're really going to look at experiences, particularly today, through the video and through some of the discussion around giving students an opportunity to have experiences that provide them predictive and explanatory power. So how can they really understand how the world works and explain it? As Ted showed you earlier on the slide with the science and engineering practices, we've been very often focused on the idea of, with young students in second grade, with planning and carrying out investigations. And these are the science and engineering practices, so are much broader than that. Now there's 8 different different tools that students will have to use for the purpose of learning the disciplinary core ideas. What's interesting, what I'm really loving about my experiences working with teachers with these 8 practices, is we're starting to see how when we engage students in just one of them, how each one of them starts to really become obviously needed. So as soon as students are planning and carrying out investigations, then they're also next, asking questions and developing explanations and engaging in argument from evidence. And that's really where we're heading. We want to move from carrying out investigations toward the idea of developing explanations and arguing from evidence, so that we can really capitalize on students' experiences with phenomena and provide them almost as many opportunities to do these other practices as we have been providing them in carrying out investigations over the past few years when we've been using those hands-on activities. So today we're going to focus particularly on the physical science topic in the second grade, but there's also life science and earth science topics. So in the NGSS, the elementary grades are very specifically laid out, so what happens in second grade is clearly defined. Today, the physical science focus will be on matter and its interactions. And so all of the things that you see, the performance expectations, the disciplinary core ideas, the video of a teacher teaching in their classroom will be around that topic. So here's a little bit of a breakdown of that core idea of matter and its interactions. So if the students are really going to engage in investigating scientific phenomena, they're going to need to ask and try to answer some questions. So for this topic, for this core idea, one of the questions that they might ask and answer is, how are materials similar and different from one another, and how do the properties of the materials relate to their use? So these questions are directly aligned with the disciplinary core idea and really set the stage and provide context for students engaging in their experiences with a phenomenon. Students will also really be focusing on observable properties of materials. You'll see that in the video that's coming up in a little bit, and the analysis and classification of the different types of materials that second graders will engage with. So these 2 bullets, this didn't come just from nowhere. We picked these out of the storylines that are in the Next Generation Science Standards background material. So if you were on the nextgenscience.org page, this is a picture of that page, and you scroll down just a little bit, you would see a link to the storyline. So you can see that here where the arrow is showing. And if you clicked on the K2 or the 3-5, you would be able to read the storylines for each of these core ideas. It's a very powerful tool when you're thinking about curriculum development. In addition, we work with a lot of teachers, and some of this content has been moved around. You might be really uncomfortable with the content knowledge and want to feel like you need to do a little bit more background reading. And there's also some support for that right within the framework document. So for this disciplinary core idea, if you were in the framework for K-12 science education, you would actually find the background for the core idea right on page 106. So we wanted to make sure that we showed you that while this stuff might be new, all this different content and performance expectations, there really are supports already in the materials that you would be able to access. So this slide shows the page from the Next Generation Science Standards. The top area, this white box here, as Ted showed us earlier, shows the performance expectations, and then the foundation boxes in the colored columns underneath the performance expectations. So today's focus area is going to be on the performance expectation that's circled here. Construct an argument with evidence that some changes caused by heating or cooling can be reversed and some cannot. So we're really looking at this one performance expectation, but information that supports that is found in each one of these columns. So the science and engineering practice of constructing an argument, disciplinary core ideas, and then the cause and effect and patterns in the as a cross-cutting concept. So there's also, not only in other resources, but right there on that one NGSS page, an awful lot of background information that can help you when you're making instructional decisions about the performance expectation. So if we look more carefully at the performance expectation itself, you'll notice that this has both the performance expectation and also a clarification statement right there. Remember what Ted said from earlier, that the idea of these is that this is what students will be able to do at the end of instruction. So at the end of a particularly long set of carefully scaffolded instructional activities, students would be able to construct an argument with evidence and really focus on the idea that some changes can be reversed, that are caused by heating and cooling can be reversed, and some cannot. It's also very important to remember to look at the clarification statement, because it'll give you a great amount of information about what kinds of examples might be used and what things are appropriate to think about when you're looking for ideas for instruction or for the assessment pieces. So for example, here the irreversible changes would be like cooking an egg or freezing a plant leaf. So these are really just right here on this one page, there's a ton of information about what students will need to be able to do at the end of instruction. So we go back to that disciplinary core idea. So this is the content piece, right? The stuff that we're sort of most familiar with because it's been what we have focused on and for most of our standards documents for quite a long time. And then when you start to really look at the disciplinary core idea pieces, you'll see that it clearly states the kinds of things that you'll need to be attending to. For example, it says that we're worried about solids and liquids. You might notice that it doesn't say anything in the second grade level about gases. And that matter can be described and classified. So we're really looking at classification, at cause and effect, so the changes that are caused by temperature within that disciplinary core idea. So one of those big conceptual shifts of the NGSS, and I think one of the most powerful pieces of this document itself, is the idea of the progressions within all of the three areas: the science and engineering practices, disciplinary core idea, and the cross-cutting concepts. In this case, we're showing the disciplinary core idea progression for this piece about matter and its interaction. So I did do a little editing from the document so that we could fit it all on one slide. But as you skim across this, you really start to see that the foundational pieces in second and fifth grade in the elementary school become very critical to what students are expected to learn in the middle school, and then the complexity and sophistication of the ideas that are in the high school. So all of the important pieces that happen in second grade are good for second graders And also, they lay the foundation for the ideas that are going to happen later, and the sophistication of the ideas that are necessary for middle and high school attainment of those performance expectations. Another great tool for developing materials or thinking about what is it that I'm really supposed to be teaching are the grade band endpoints. So here we put the grade band endpoint for the physical science core idea. This was exactly taken from the framework for K-12 science education. And somebody asked on the chat about the link for that. So you can see on the slide, and Christina has put the link for the framework right in the chat box. So you can really just click on that. It'll take you right there, and you can get that for free. And as Kathy said earlier, this is a mandatory reading, I think, for every teacher. It is pretty substantial a book. It's 400 pages. But it's something that everybody needs to be familiar with. So you can see that the critical pieces that align with the performance expectation we're focused on today are highlighted here. But it's really this one paragraph gives you some great ideas about what we might do in instruction. All right, so we're going to stop here and do a little checkpoint. We're going to focus that on two big ideas. One is making sense of those second grade performance expectations, or preparing to teach the content of matter and its interaction. So Christina, this is, I'll turn it over to you so you can help us with this checkpoint.
Actually, I'm going to help out at this stage here, and so folks that have questions, to please post them in the chat window here. And Amy will get those links posted over for you. We'll get somebody to do that. But what questions you have about making sense of the performance expectations or preparing to teach the content of matter? So Nancy's got I think a really great question here in terms of how many lessons does it take to help prepare students that they've accomplished or are ready to accomplish a performance expectation?
Let me take that one, Ted, because I think we're going to address that in the next section. We're going to shift to teaching this performance expectation in the next segment of the webinar. And I'll talk to you a little bit about what comes before the lesson that you're going to see in the video and what comes after. So you might get a sense of the sequence that you might have to go through to be able to reach that performance expectation. Great.
So I'm assuming as well that we probably also going to have a chance to address Jean's question about a concrete example of a lesson. But I think we could maybe take on here, Emily's asking, what would you do if some students start bringing up the concept of gases? How would you deal with that?
Okay, I'm going to tackle this one. If students bring up the concept of gases, I would be ecstatic. I would, we could talk about it, we could think about it, we could work at it, and imagine what that means for different applications. The idea of the endpoints, the grade level endpoints, and the performance expectations is this is the stuff that all kids need to be able to do. This isn't a ceiling. So if the ceiling in your classroom includes students talking about gases at second grade, then we talk about gases at second grade. Is it necessary? It's not necessary because that would be outside of the boundary for expectation for second grade. That would be my answer.
I really like that response of how important it is for teachers to listen to our students and think about what they're saying, what their questions tell us what they're ready to learn about, and rather than trying to impose what we think they need to learn about, to listen to what they have to say here. Erica asks, I think, a question that resonates with all of us is, how do we deal with the situation when students haven't had the prerequisite concepts built in it? So if you're a 3-5 teacher and the students aren't aware and understanding disciplinary core ideas that are down at the K2 level, and you're responsible for now teaching them the ideas in 3 through 5.
I'll try that one. I think we need to start where our students are. It's very important that they get those foundations as we're working towards that next section. We don't want to create any gaps or block holes for our students. We want this to be a coherent storyline as our students grapple with this phenomena. We want it to make sense. So my answer is I would definitely start where the students are.
Great. Why don't we just do one more question here, and then we'll come back. I know we've got more than one question waiting in place here, but we'll have some more time for questions. And Kaylee's asked, or I hope I pronounced your name right, do you start by introducing the definition of matter and discussing that, or just jump into solids and liquids? And how does vocabulary play a role in instruction here?
This is Carla. I'm thinking what you might see in the video that comes up reflects the way that I tend to think about this is allowing children to have opportunities to interact with phenomena and introducing terminology on a need-to-know basis as it's appropriate, so that students have had the interactions and have something to attach that terminology to. And you'll see, we'll talk a little bit about how the teacher does that in the lesson that I'm going to share tonight.
Great. So why don't we step forward here, and then we'll come back for some of these questions. I'll start saving them up.
Thanks, Ted. I'm counting on you to save them up for us. So, and I appreciate it's an excellent group tonight in terms of your participation so far in the webinar. You have to know it's the weirdest experience in the world, sitting locked in my office staring at a screen. So the only interaction I have with you is you responding to polls and talking in the chat box. It really helps us feel like we're actually interacting with someone out there. So thank you for doing that. As we switch to part 2 of the seminar, we're going to focus on teaching. And before we do that, we'd like to take a quick poll on teaching matter in elementary school. And as a group of presenters, we got together and talked about the ways in which we have seen, or the ways in which we have taught matter in elementary grades. And so this focus on change of state, mystery powders activity, classifying materials are things that we've noticed are fairly common. If you have other things, you can type them in the chat box, but Christine is going to remind you of how to actually engage in the poll.
Okay, so it's just under your name there. You have those 4 buttons. I know a few people have responded already. So go ahead and choose. You'll click on that button that has a number, the letter A there, and then let's give us your answers. We'll give you about 30 seconds or so to work on that, and then I'll publish the results on the whiteboard.
Okay, thanks, Christina, and thanks everyone who was able to participate. I see a lot of the answers coming in the chat window. It looks like people wanted to select possibly more than one, and we also see some engagement with phenomena, the use of oobleck, and some other ideas there. So thank you for responding to that. So let's return to the performance expectation before we see the video so you can have that clear in your mind. The practice we're going to be focusing on is argument with evidence. When we talk about constructing an argument, we're talking about the kids being able to construct an argument with evidence with support from the teacher. The core idea is this notion of reversible and irreversible changes, which is pretty interesting because second graders often know about melting and freezing, and the most common example that I've heard them use in classrooms is around ice melting or freezing water to get ice. But they oftentimes have not thought about this in terms of reversible and irreversible changes, and so moving them towards that performance expectation is pretty important. When we talk about this particular teaching video, as with the other videos that we've included in the other webinars, it's not intended to be perfect teaching, but rather it's an example of a teacher who's intentionally working on the specific content and practices that relate to the performance expectation that we're highlighting. We want you to know that this classroom may not look at your classroom, but we hope that you still can find ways to benefit from this teacher allowing us to come into her classroom, video record, and observe. We are in central rural Pennsylvania, which is the geographic center of the state, so we're between 2 and 4 hours from lots of urban centers, but we ourselves are quite centrally isolated, as a colleague of mine likes to say. The lessons are from the second week of November, and if you do your math, that was just last week. So if you are thinking, what does a second grader look like at this time of the year, this should be a pretty accurate representation of that. The class consists of 24 students. 3 of those students have formal IEPs, and 4 are designated as ESL. The teacher herself, Ms. McCracken, graduated from Penn State University from our program in 2009, and she's been teaching ever since in the local area. She also just earned her master's degree this year in 2014. The lesson that you're going to see, I have to tell you, editing these down are really challenging because we need to get to 5 minutes, and the lesson itself that this particular video came from was a 90-minute lesson. So keep that in mind as you're watching this. We have to be really targeted in our observations. And as always, please show respect for colleagues who share their classrooms with us. I think it takes incredible bravery to allow us to do this, to put your practice out there so that other people can learn from it. So please show Ms. McCracken and her students the respect that she deserves. And if you choose to use this video in future professional development or with a class, please make sure that you set the context with this slide so that people understand a little bit more about where we're coming from in the video. I also want to make sure that I'm thanking the team of people working behind the scenes to co-plan with the teacher and collect the video and do some of the legwork that's incredibly important to be able to bring this to you in the webinar tonight. I mentioned this a little bit before in response to a question, but in order to really understand what's happening in this lesson, you should know a little bit about what came before and ultimately what comes after. So this teacher has spent a lot of time assessing students' prior knowledge about solids and liquids, and then helping kids explore lots of solids and liquids and their characteristics to come up with working definitions that they could use when they were talking about characterizing and classifying solids and liquids, examples of solids and liquids in the classroom. And before the clip that you see, the kids were starting down the direction of making predictions about what happens to solids in the presence of a source of heat. As you watch the video clip of the lesson, it may be useful to think in terms of what students are doing and what teachers are doing. So for example, how is the teacher scaffolding the experience of negotiating the claim? And from the student perspective, how are students actually contributing to the evidence-based claim about what happens to solids in the presence of a heat source? So with that, I'm going to turn it over to Christina to help us launch the video. Ultimately, when we come back together, we're going to ask you to reflect on this. And what we really want to hear from you is how did the teacher support learners in developing towards the performance expectation? So if you can kind of keep that in mind, the video clip is about 5 minutes long, and then we'll come back together. So Christina, can you help us out with this?
Yeah. So everyone, there's no need to copy down that link that you see there on the whiteboard. We're actually going to push the video out to you. So I'm going to click it in here, and it's going to open up in your browser in Firefox or Chrome or Explorer, and then it'll start to play itself. When you come back in the room, I've changed the poll from an A, B, C, D, E to a check mark or a red X. So when you're back in the room, please feel free to click that green check mark so that we know that you're back in the room and we can get started. So with that, I'm going to push the video.
Hang on, folks. We've noticed we've got the wrong video. We're trying to see what we can do here to get you the correct one out.
Okay, everyone, our apologies. We have a little mix-up with the link there. So if you can go ahead and stop that video. My apologies if I'm talking over you. Stop that video. I'm going to put out a new link, and it's the one that Jason has put there as well, and I'm going to push that to you. So ignore that first one. Our apologies. Watch this next one, and when you're back in the room, give us the green check. Okay, here we go. Okay, it looks like we have more than half of the participants back in the room. So my apologies if I am speaking over some of you who are still watching the video, but if you could go ahead and press pause or stop on that video and come back into the Blackboard Collaborate room, we'll continue from here.
Thanks, Christina. I'm sorry to those people who are having difficulty with the video. I hope that you're able to access that later. But for those of you who were able to see the video, I would appreciate it if you could comment in the chat window right now about how the teacher, what you saw as the teacher doing to support learners in developing toward the performance expectation. So just take a couple of moments to respond there. So people like the inquiry style, asking questions, specific language about scientific practices, the fact that the teacher kept pressing for evidence and seeking clarification, focusing on their observations, what they saw, getting students to think more deeply, the probing questions, what do you mean by melting? I mean, it was clear that she was really trying to get them to talk about what is a liquid versus what is a solid in the language that they had developed in prior lessons. And it was really interesting to me that some of the kids were not ready to talk about that. They would say, how do you know it's how do you know that it's changing? Well, I can see it, not it takes the shape of the container. It took a while to get to that and a big press to get to that. Using the language of claim, the notion of critical thinking. Glad some people are enjoying the What's Your Evidence book. There are other video examples that are part of the book as well as lots of vignettes. So these are, you noticed a lot of the things that we were able to pull out when thinking about this video. In particular, this teacher is really, really good at emphasizing and modeling recording observations and how to do that. So as the students were recording their observations, she was recording with them and they were talking about it. She also used multiple materials so that students could begin to identify patterns across a variety of different examples. And you've already picked up on the talk moves that she was using to really get at students' ideas. I know there was a little chatter in the chat window before about the importance of getting at students' ideas, and teacher moves and questioning are so important in terms of doing that. And Kathy's going to talk about that a little bit later. So after this lesson, I think it's important to kind of think about like what came before, but here's what came after. So students came back the next day and they were asked to make predictions about their sample and whether they would change back to solids. The samples were allowed to sit overnight, and that's what they ended up looking at and comparing their results to photographs of what they had done in the prior lesson. And of course, the teacher, there's a little bit of a sense of how the teacher worked with kids to develop claims from evidence. And this really gets at what Mary was talking about earlier in terms of how the various practices are related or interrelated. So students are carrying out investigations, they're collecting data, and then they're using those observations, which are data, to support the development of explanations. And they're arguing, they're really working through and negotiating constructing the explanations or the arguments from evidence. So given that we're using this language back and forth, it's probably important to take a moment to talk about how constructing scientific explanations and arguing from evidence differ from one another and how that plays out in NGSS. When we talk about scientific explanations, using observations and science ideas to construct evidence-based accounts of the natural phenomena, But the argument from evidence is the process of reaching agreement. It's that negotiation. It's that back and forth. It's that pressing for evidence and looking for what patterns you can identify and how you can construct that claim that will contribute to your ultimate scientific explanation that you're trying to develop as a student, which might actually take several sequences of claim, evidence, and reasoning to pull off. And so to do this, we found it very helpful to draw on the work of Joe Kraychick and Kate McNeil with the claims, evidence, reasoning framework, where the claim is a statement or conclusion that responds to the question, evidence is the data that supports that claim, reasoning is the justification that shows why the data count as evidence to support the claim, and it includes appropriate science ideas, and ultimately a rebuttal whenever possible. So this is another way to represent the relationship between claim, evidence, and reasoning. Again, keeping in mind that this always necessarily involves engaging with phenomena, asking questions that require investigation, and it also shows, which I like about this, that it's from the evidence that the claim, which responds to the question, is developed. So let's go through this really quickly. With the CER sequence that came from this lesson, it actually came from a sequence of lessons. So the students were engaged with phenomena around solids and liquids in the presence of heat, and they were trying to construct a claim that would answer this question. So their data, their evidence that they drew on was the observations of the crayons, the butter, the chocolate, and the ice. And basically they noticed in this lesson that they melted in the presence of a heat source, and the next day they found out that everything changed back except the ice. And the ice is sort of the piece that they use to build to the next sequence in the lessons. You'll notice that the teacher, in terms of getting that evidence and making sure that it was in a form that kids was accessible to kids, had a lot to do with the way that they recorded their observations. And one thing that they did, this particular school has iPads in kindergarten, first and second grade, so she had kids take pictures on the day of the lesson that you saw so that they could use those pictures and compare that to what their results were the next day after the samples set overnight. This teacher, as we mentioned, is also very good at getting kids to record their observations and writing about this. So she uses science notebooks, and this is a particular page. Her science notebooks are loose leaf so the pages can fit into the notebook. So she's very good at doing this as part of data collection. And from this evidence, students were able to come up with a claim that some solids change to a liquid when heat is added. When the source of heat is removed, some materials change back. It was after this that the teacher introduced this notion of change of state. And that's really important because kids had experienced it, and now she could attach language to it that helped complete the explanation that they were trying to build around this. She also recorded kids' wonderings. The wonderings are incredibly important because in this case, kids were commenting that in that next lesson, we know it needs to be colder for water to change to ice. But the interesting part was, will other liquids change to solids in the freezer? And that leads to a follow-up investigation that comes directly from the kids. The teacher in this case was documenting, because I hope what you're seeing is that it takes many lessons to get to this particular performance expectation. Lessons on solids and liquids and their characteristics, then changes in solids and liquids that are reversible, and ultimately they'll move on to irreversible changes. So how do you document over time these claim, evidence, reasoning sequences? And so this particular teacher was using a KLEWS chart. And a KLEWS chart is a modification of a reading comprehension strategy that many elementary teachers know as KWL, with a couple of really important distinctions. One is that the K is not what we know, but it's what we think we know. It's where teachers record students' beginning ideas and predictions. The L is for learning, which is where we put our claims. The E is for evidence. W is for wondering, so that question that the teacher captured, she can record there and then come back to. And the science ideas, so these are the scientific principles and terminologies like change of state that were eventually introduced. The other really important thing or distinction between KWL and KLEWS is that this doesn't happen in a linear order. So as we saw in the framework, evidence comes first and then you generate your claim from evidence. So those are a couple important things to keep in mind if you're working with KLEWS charts. And speaking of wonderings, I think this is a great example of how it feeds, how the practices are interrelated, and engaging in one set of practices leads you back to others, as Mary talked about in the beginning. So we talked about the freezing piece. Another child brought up the example of clay. Clay gets hard when you heat it up. Can we change it back? So the teacher records this, and then the class will eventually come back to that idea when they start to talk about some of the irreversible changes. So talk helps us throughout this whole process, this idea of negotiating these ideas, and talk being an important contributor to meaning making. And so Kathy's going to take us through next how talk is so important to realizing the vision of NGSS in the classroom.
So we've been talking about talk, and we're doing a lot of talking at you, but I don't want to spend too much time here, except that this slide is a little bit different than it has been before. We've already talked about the fact that talk provides that lens into student thinking, but one of the things it also does is support rigorous science learning by ramping up that academic language, by providing opportunities for students to make the connections by hearing, speaking, and listening to one another. Again, as we've been talking a lot about evidence, students are being encouraged to think and argue scientifically using evidence. It gives students a chance to practice collaboration and to work as scientists. And it also provides an access place for all students to get in because they feel safe and they can learn from each other and they know their ideas are valued. It talks across it connects across the disciplines, and my little cartoon, talking is good for the brain. So what do it have to happen for productive science talk to happen? Well, the biggest piece is that we have to believe in our students. We have to believe that they can do it. They can have these productive conversations. And I'm talking about all of the students. We also have to make sure we have norms, and those norms really should be specific to science meetings because sometimes those norms are different from other classroom meetings. When we pull together a science meeting, it really needs to have a purpose, a good focusing question that will lead to deeper student understanding. And something that is really important is it's also important for teachers to have a grasp of that content. And that content doesn't mean you have to have had a course in that content, but it does mean you need to have done some reading in the framework. And if you're working on intentional planning, you will be able to figure out some of that content. Norms, I'm not talking about it all. This slide has been here forever, since we began the product. I do want to spend a few minutes on the essential elements in terms of constructing arguments for evidence and using talk in this way. A focused initial question is so important. It's also really, really important that your students understand that this particular time, this science talk, is not a sharing time, but this is the time when we're building on the ideas of others, we are making meaning, and that evidence is required, and that we're using the relationships and the patterns that are found in the group data to build that shared understanding. Facilitating productive talk, again, I want you to just look. One of the things that I think is really important, we don't always do, or I know I have often forgotten this, is to make sure that the students need to bring the tools that they have to bring to the meeting. Also, as a teacher, we need to notice who's talking and who is not talking, using wait time, and we need to employ the talk moves that have been spoken about since the beginning of the webinar. These talk moves come from? What's your evidence? Really helping our students, especially young students, to refocus on that guiding question because it's easy for them to become distracted. To help them consider alternatives. You know, is there a different claim that better explains the evidence we have? All of these are important things to think about. Talk is very important, and it often is the piece that gets left out of science instruction. And I'm going to hand it back to Mary.
Great, thanks, Kathy. I don't know about all of you, but I'm a little exhausted from all of this. So we've really run the gamut from starting to, talk about how to move beyond the hands-on activities and why we want to have students doing this kind of work, the disciplinary core idea, reversible and non-reversible changes, learning about the disciplinary core ideas of science and engineering practice, and the cross-cutting concepts. So when we really think about these performance expectations, we focus today on just this one performance expectation. But when you look at this entire set, it's really these all go together. These really focus you on the kinds of opportunities that students should have in learning. And we want to think about them as a bundle. So we're not really focusing on just teaching toward one performance expectation, but rather thinking about all of them together and how the use of them together and the consideration of them as a group really pushes our instructional planning to a much more deep level and much farther away, again, from the just doing some hands-on activities. So we've done all of these things. We've focused on learning progressions, and Kathy did helped us with the strategies for rich talk, some interdisciplinary connections through that talk with the ELA standards. And then what do we know? And all of this is a lot. It's a lot for us to do. It's a lot for us to wrap our heads around, and some of those changes are going to be pretty substantial for us. But what we do know is that we've got some time. We can take the time to really be thoughtful, to work with our colleagues, to use tools like this webinar and other NSTA tools to really get focused on what are the kinds of things that we're going to need to do, and to get organized and make a good plan so that we don't become overwhelmed with all the changes, and we can really tackle them perhaps one thing at a time. So that's my conclusion, and now I'm going to turn it back to Kathy.
So, as Mary said, we have been through a lot here in our time together, but I just want to bring us back to where we started and remind us of the purpose for this webinar and why we are here. One of the things is we want to make sure our students have a meaningful science learning and that they get the opportunities over time to practice the work of scientists and the talk of scientists. We need to know that today we hope, and the work that we shared with you will be the foundation for future learning in science. We hope we've given you an opportunity to think about NGSS at grade 2 and some of the teaching strategies that might go with that. We hope we've also made a connection to the ELA and mathematics, because one of the things I think we know as elementary teachers that time is of essence, and the more intentional connections that we can make and use our time well together for both science and literacy, that we'll get a lot of bang for our buck, and our students will get quality instruction. A piece of the work that we've been doing from the very beginning is the development of a community of practices, we hope, that's really focused around the elementary grades. One of the places that this community practice, can continue to evolve is at the Learning Center, which I'll talk a little bit more about in a minute. And at the Learning Center, again, that's the place that will give you access to instructional resources for teaching as well as others. And I'm going to talk about a few of those right now as we move on. Oh, I'm sorry. I'm going to stop for a minute. I forgot about this one. So thinking about all that we've just shared with you, which was an immense amount of information, what is one idea of practice from this webinar that you will take back and use in your instructional setting, whatever that may be? Please write in the chat window.
This is great. I hope you're having a chance to look at each other's comments, everything from the science talks and the talk moves to the different kinds of aspects of the investigation that the teacher was doing in the video, using photos from prior observations the next day. We find this especially helpful when kids, especially younger kids, have difficulty with their fine motor skills and drawing accurate representations of their observations. KLEWS chart, some of the resources that were shared tonight. We're really excited that it looks like most people were able to find something that they could take back to their classroom and use with their colleagues or with their students. I love the idea of melting chocolate in your mouth. One of the kids in the video that was not in the video segment that I edited down to talked about he knew that it would melt because he had this big long story of how he melted something in his a chocolate bar in his pocket at Halloween or something like that. So I would like to try it in my mouth, actually. I'm a big fan of chocolate. So experiment, the use of evidence, the claims evidence reasoning format, that's been very helpful. So thanks to Ted and our moderators and others for putting some resources and some links out there for people. Kathy, you walk us through the Learning Center?
Sure. So here we have the Learning Center, which I spoke about just a few minutes ago. This is one of the places I spend an awful lot of time. Even when I'm not working as an online advisor, there are amazing resources here from web seminars, the archives of what we've done. There are great conversations going on in the forums, and I'd really like to see some of you join me in some of the forums. I'm always trying to get a conversation started. But there's so much more here than I can even talk to you about. I have a library here in the Learning Center which has, I don't even know how many resources I've put together. And it really works because when I need something, I have a place, I have a go-to place, I know where it is. And there's much more in terms of keeping track of your own professional development and lots of things. But you really have to spend some time and click furiously. You're not going to hurt anything, and you'll find so many more interesting things that can help you in your classroom. So, and here are some of the instructional resources that I have used as I was thinking about the talk pieces. The Talk Science Primer from Sarah Michaels and Kathy Connors, Science and Natural Fit from the work of Karen Worth. Carla's book, What's the Evidence? I have to say that as I was thinking about constructing my own slides on constructing the evidence, and I got a question from somebody just last night asking me for a place to go to find the difference between argument and explanation. And I sent them right to What's the Evidence, because it's great, get great information. But somebody earlier asked for the ideas about picture books. One of the things I have here is What's the World Made Of? Another one is there's some great probes from Paige Keeley. Mixing Matter in Science and Children, and that can be found in the Learning Center. So again, I cannot emphasize enough the value of spending time in the Learning Center looking for resources. Some of these resources have been gathered for you for this particular collection, but feel free to add to them at some point. So thank you, and I'm handing it back to Ted.
Great, and I'm going to sort of do the same thing in terms of pointing out some resources that you want to be aware of. There's obviously the official website for the Next Generation Science Standards, nextgenscience.org, and also my favorite place to look at is nsta.org/NGSS, the NGSS at NSTA hub that has a ton of resources, sort of the best place you can go to sort of find lots of information about NGSS. As Kathy was just mentioning, there's a discussion forum in the listserv, and also in the Learning Center, I should say, and we have a listserv for NSTA members. There's one specifically on NGSS if you want to be involved in that. I hope you've liked tonight's web seminar. We've got more coming as we're going to work our way through the grades with our three musketeers here. They're all on Wednesday nights from 6:30 to 8 p.m. We've got archives coming out of our ears in terms of pieces. There are over 30, I think we're getting close to 40 different web seminars that have been archived over the last several years on the practices, cross-cutting concepts, all these different pieces, as well as a huge number of journal articles NSTA has done around the practices, the cross-cutting concepts, and NGSS in general. We have a huge number of books in place here. The framework, the standards, NSTA has reader's guides to each of those, some other new books, and then I have to toot my own horn. We've got a number of books here that are just now, it's the first time I can announce at a web seminar that these are available, that are a quick reference guide that have a lot of different pieces around the standards for you all. You can get NGSS, there's an app to use for the NGSS, so you can always have it nicely on your phone. We are going to have a huge conference in Long Beach, California coming up right after Thanksgiving. I think I just heard there'll be over 4,000 attendees there. I hope to see some of you there. Please stop by the NSTA booth and look for me there. Also, even better, our national conference in Chicago, our STEM Forum in Minneapolis. Again, lots of different pieces. We'll have a whole day of customized special things around NGSS at the Chicago conference. And then down the road, future conferences, maybe we're coming to a city near you. So please stay in touch. With that, I want to thank you all for being here, and really want to thank Carla, Mary, and Kathy for what they've done tonight. I'm going to pass things to Christina, who will talk about how you do your evaluation, and then we'll come back for some more questions with the gang.
Okay, great. And before we move on, let's all get on our emoticon and give a round of applause for everyone, to Carla, Mary, and Kathy, as well as Ted for jumping in and leading some of the questions and giving some more information about NSTA. So that was a great job. Our apologies for the one video issue, but we managed to get right back on track. So thanks for your patience with that. And in addition to thanking our presenters, and again, thanks for all those rounds of applause and all those thumbs up. That's really great to see. We'd also like to thank the Carnegie Corporation of New York for sponsoring today's web seminar. And last but certainly not least, the entire NSTA team, so both within the larger team at NSTA as well as the web seminar team, which includes Jeff, who's here with us tonight as well, helping out with all the technical issues. So huge thanks, as always, for putting these web seminars on and making them run so smoothly. You can find resources related to today's presentation by going to the web seminar collection in the NSTA Learning Center. I'm going to go ahead and put the link to the collection in the chat box there. That's going to include the archive of the web seminar, not right away, but it should be there the next day or so, as well as the presentation slides, which are already there. The collection may also include journal articles and lesson plans, interactive content modules. These are called science objects and SciPacks. And links to other helpful websites and multimedia. So go ahead and keep that link with you so that you can use it. And you will be receiving, for those of you who are here live with us today, you will be receiving a link to access the archive and the collection later. Now, looking forward, we have a number of web seminars that are coming up, so feel free to have a look at some of those dates. There are even more groups and web seminars that are available. I'm going to put the link to the main web seminar page in the chat box there so you can have a look, and hopefully you enjoyed tonight's seminar and that you'll come back for more. So look at those 3 that are there, as well as there's many more in the pipeline as well. So with that, I'd like to thank everyone for your participation. For those of you joining us live, please do stay on the line after our recording so that we can give you the evaluation link. And with that, we also look forward to seeing you again at another NSTA web seminar. Thanks, everyone.